everyone, welcome to Spratt STEM Academy. This is going to be a video on balancing chemical equations. I recommend watching my components of a chemical equation video, which I'll have in the description below, before watching this video. It goes over some of the basics of a chemical equation and things to look out for. But today we're just going to be doing some examples, and I'm going to go over the easiest steps to balance any chemical equation. So let's get started. Here I have the reaction H2O yields H2 plus O2. Now, the thing about balancing reactions and balancing equations is that you want to have the same amount of each element on each side of the arrow. So notice that on the left side of the arrow we have H2O, and on the right side we have H2 plus O2. Now remember, each element needs to be the same on either side of the arrow. So the first step is write out your balanced or your unbalanced equation, which we have here. And we know this is unbalanced because why else would we be balancing it if it were already balanced? And then your second step is you want to write a list on each side of the arrow. So I put like an imaginary line here, and I'm going to write out a list of the elements that I have on each side. And we know there's going to be the same elements on either side because this is a reaction. Everything has to be balanced. That's just how chemistry works. So here on the left, we have H2 and we have O. We know this 2 goes with the H because it's on the bottom right of the element, as we can see here. So we have H and O. So I'm going to write H and I'm going to write O because those are our only 2 elements that are in this reaction. And it's going to be the same on the right side of the arrow. So we're going to write H and we're going to write O. Now the thing is to count how many of each you have on either side of the arrow. So in our H2O, there's 2 H's. And do we have a subscript on our O? No. So we just assume that there's only one O. Okay? Now do the same thing for the elements on the right side. So let's start with H2. The subscript by the H is telling us that there are 2 H's. And here on our O2, which is oxygen gas, by the way, our subscript here is telling us that there are 2 oxygen atoms. So now we see that we have 2 H's and 1 oxygen on the H2O on the left. And on the right side of the arrow, we have 2 H's from our H2 and 2 oxygens from our O2. Okay, so once you have your lists, the thing about balancing reactions is you're going to change the coefficients of each element, which are numbers that you're going to place in front of the elements, okay? And these numbers are multipliers of the subscripts. So right now, all of our elements, we have blank coefficient lines, okay? The purpose of what we're trying to do is to change each element's coefficient so that we can balance these numbers from our lists, meaning we want to have, for example, 2 H's on the left, 2 H's on the right, and however many number of oxygens we have on the left, it should be the same on the right. So right now, since there are no coefficients in front of each element, we could assume that they're 1, but that wouldn't make this balanced because then that means that we have 2 H's and on the left and 2 H's on the right, which is balanced. But we only have 1 oxygen on the left and there are 2 oxygens on the right. So technically, this is not balanced. Now, what can we do? If we see here for our O on the left side, for our reactants, there's 1 O and 2 H's. Now, remember our H's are already balanced, so I'm going to put an arrow between here saying that they're already balanced. But our O is not balanced. So we look at how many we have on the left and we compare it to how many we have on the right. Is there a number that multiplies 1 to get 2? There is, and it's 2. And we put that coefficient here. So it multiplies out to that O, meaning that now we have 2 oxygens instead of just 1. But the thing about coefficients is that it also multiplies to everything that's in this compound. So it's not just going to go with the oxygen, it's also going to go with the hydrogen. So there's 2 oxygens because it multiplied with the O. And now there's 4 hydrogens. So I'm going to erase this arrow. There are 4 hydrogens because this 2 multiplies with the subscript that's on the element. And remember, the O didn't have an explicit subscript, so we just assumed that its subscript was 1, and that's why we now said that there's 2 oxygens. But since the H has a subscript of 2, we multiply it by the coefficient to get 4 hydrogens. Okay, so now our oxygens are balanced. They are balanced and ready to go. But now our hydrogens, which we thought were balanced, are not balanced because on the right side we only have 2 and on the left we have 4. This is a little easier to change because if we know we're just dealing with hydrogen, we look at our hydrogen element, which is here, we have H2. Can we put a coefficient in front of it that would make it to where we have 4 hydrogens? Yes. What number can take 2 to 4? It would be 2. So our coefficient is 2. We know that when we multiply this out, 2 times the subscript 2 changes this to 4 hydrogens. So is this balanced now? Yes, it's balanced. So I'm going to erase all these arrows so that we can see things a little more clearly. But now when we compare, we see that we have 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, and 2 oxygens on the right. Now, notice our coefficient for the H2O is 2. Our coefficient for the H2 is also 2. But the O2 on the right doesn't have a coefficient, at least not one that we changed. So when there's nothing in front of an element, we just say it's 1. Okay? And that is the complete balanced equation for the reaction H2O to H2 plus O2.